Hello, everyone, and welcome to Azim Premji University's Alumni webinar series. Today's session is titled Being Future Ready for Climate Change. We have from our undergraduate program Amruta CV and Sahil Regi Mathew, both alumnus from the Bachelor of Science in Physics program 2016-2019 batch at Azim Premji University. Amruta and Sahil are going to be in conversation with Kripa Gauri Shankar, who's a faculty at School of Arts and Sciences at Azim Premji University. Today's webinar is extra special because we have alumni from the undergraduate program joining us for the first time. So a huge shout out to Sahil and Amruta both. On behalf of all of us, I extend a warm welcome to all of you. I hope you enjoy the webinar. Kripa, over to you.
Thanks, Shuchi, for that introduction. I'm very, very thrilled to be in conversation with Amruta and Sahil, our illustrious alumni from the second batch. And since I'm in the alumni committee, I pulled some strings and got a couple of physics students on board. And it's about time. So before we get into what they have been doing, I would also like to just say that Azim Premji University has the undergraduate program has a interdisciplinary studies stream in climate science, and the university also has a research center in climate change, which is going to be coming out with a report on how climate change affects India in the Indian context. So since this is such a hot topic, we thought that we would get some of our physics students who have gone into this field and are doing their higher education in areas which are related to climate change. Okay, so I'm just going to introduce Sahil and Amrita briefly, and I'll let them tell their own story. So both Sahil and Amrita, of course, we like all the batches which have graduated from APU, but we have a special soft spot for the second batch. Don't tell anybody else. So Sahil and Amrita are part of this very lovable group of students, and they also always were the people who sort of pushed boundaries a little bit and did things outside the normal curriculum. So Sahil actually went and did a economics minor, and Amrita did an applied maths minor. And Amrita has been interested in this also because of her hobbies, which include trekking and the Himalayas. And I believe that both of them have sort of married their different interests while choosing their future trajectories. They're also known to enjoy chips and hot chips and coffee together, is what I've been told. Oh my goodness. So, just a second. Where am I? I'm back here. So yeah, we were just discussing how my cat would probably be the highlight of the show. So yeah, before any further disasters, I'll let Sahil and Amrita just talk about their sort of life history immediately after they left Azim Premji University. So maybe first Sahil and then Amrita.
Yeah, thanks so much, Kripa. I don't know how you got the coffee and the hot chips part, but I think you maybe have seen us around campus eating hot chips and coffee. But anyway, so after APU, I graduated in 2019 with Amrita, and so as Kripa was saying, I did physics and economics, and which is quite of an uncanny combination. But at that point, I was like interested in both these fields, and the university gave us the opportunity to do those kind of combinations. So I went for it. But the result was at the end of my degree, I was very confused. I didn't really have a path that I saw myself getting into. I was quite certain I didn't want to pursue physics as through an MSc in physics, or even work as a researcher in a lab or anything of that sort. Basically, I didn't know what to do after my UG education. I had a lot of interest. So that was the thing. So I didn't think I'd have a lot of social science based interest, but after 3 years, at the end of that 3 years, I started getting quite interested in a lot of social questions, social science based questions, and that kind of confused me because my formal training was different in physics, right? And I couldn't find myself anywhere, so I kind of just took the year off. And to be honest, like during that year, the year felt like a waste of time while I was in that year. But looking back at it now, it feels different. But essentially, through that year, I just did whatever I wanted to do. I read books. I played some music. I did a musical with my old school. I played in some bands. I was basically doing these kind of things right after. And but in that process of um, in that year, these interests were still brewing, right? They're still there somewhere behind. I was also reading a lot, not with the intention of um, I'm reading so that I find my purpose or anything of that. Not reading because I'm generally interested. But as I was sort of reading more and more, I somehow found myself getting quite interested in water. I think principally because I was, I was interested in environment and ecology and sustainability, and all these kind of topics come up in many of our classes at APU and things like that, and they were for sure one of the interests that I had. But I found water to be a very interesting space. It was kind of I felt very close to home because I mean I stay close to the burning lake next to Bandu, right? And I was reading books that were sort of prompting me to think about water. And what I found like quite interesting is that um, everybody from across many disciplines have some sort of say in water. So you have historians writing about water, you have sociologists, you have physicists and natural scientists, you have economists, you have all of these sort of people who are sort of chipping away at water as water. So I started getting quite interested in this domain, and specifically to India. While I was reading more things, I saw a lot of recurring names in this sector, and of people who are sort of pioneering these fields. And I basically tried to understand if there's a course that would teach me water, which is not sort of like in a civil engineering hydrology way, which is how it has generally been studied. You figure out how to manage a dam, you figure out engineering structures to supply water to people. I was not interested in that. Neither was I interested completely in an anthropological or sociological study of water. I wanted some sort of a program where I could have some sort of a scientific base, understand the science behind how water cycles through our environment, but also have a very core social understanding of this water crisis. And which seemed like a lot, but I found a course and I enrolled for this 2 year MSc in Water Science and Policy from Shiv Nadar University, and I just graduated from that program. It was one of the COVID batches, but thankfully could do extensive field work through this program, which I have pictures of, which we will get into later, and things like that. So, yeah, so that's where I'm at right now. And currently, I'm working at a think tank in Bangalore called C-STEP. It's called the Center for Study of Science, Technology, and Policy. And within C-STEP, I work in a small group that looks at climate risk and adaptation. So I've just started there. Yeah, so that's me.
That's great. Thanks, Sahil. So, from chipping away at water to chipping away at what, ice in the close to the Arctic, we will go to Amruta.
Yeah, thanks for having us, Kripa. I'm thinking of me and Sahil both. And actually, Sahil, it was me who told Kripa about hot chips and coffee. But yeah, anyway, yeah, just maybe I can share about what I did right after bachelor's. I actually prepared a few slides, so maybe can we have them up over there? Yeah, okay, thank you. So yeah, Sahil and I were in the same batch. We did physics from Azim Premji University, and I had a minor in mathematics. And we graduated in 2019. And after graduation, I wasn't really sure what I wanted to do, and I wanted to do a master's, but I wasn't sure which area I wanted to do it in. And yeah, actually, I heard about the field of climate science because of some science seminar talks that we had in at the university, and we had like some really cool professors come and give us the talk. And one of like few of them were like Professor R Shankar from IMSC and Professor like Chirag Dhara from IITM Pune, and actually spoke to them about this. And for me it was like really mind blowing because hey, like I could be, this was an opportunity for me to be like outdoors and also like do science like how I like it. So that was always at the back of my mind, and I was like, okay, maybe something like that. But I didn't want to go into academics right after. So in my last semester, I actually found out about this fellowship called as Greentales Fellowship, and it's run by a trekking company called India Hikes. So I applied for that and I got selected for it. And that's where I worked right after my undergrad and for like few months, I think. And basically at this company, I was part of like the logistics team, but we were like more focused on making treks more sustainable. So I was like based at the Manali slope, and like I would go on treks, and I would also like train the staff, and we would talk about sustainability. I think I learned more at this point. Like it was not me training; it was just like me learning a lot more from them. And yeah, it was like a very different experience from what I had before, because this was like, yeah, I was doing like small science, backyard science experiments, like experimenting with like organic soaps or like composting, like how it works on higher altitudes and all of those things. But like I think for me it was more about like learning interpersonal skills or like doing a managerial job, which was like, I think now it's I now that I see it, so it was very helpful. So I did that. And then like I actually came back to Azim Premji University, and I worked as a research assistant with Professor Richard Fernandez, and with whom I also did my independent undergrad research project. So I just came back to like continue that. And but yeah, I wasn't able to fully finish it because the pandemic hit, and then I also decided what exactly I wanted to do for my master's. So this was like what I wanted to do for my master's. I was trying to figure out when I was still working for the hiking company. Like I would work all day, and then like I would just Google climate science courses, and that's how I like came across the course that I'm doing currently, and it's called Integrated Climate System Sciences. It's at University of Hamburg in Germany, and it's quite an interdisciplinary course. It's also a 2-year course, and you get to do a lot of courses in sciences, biogeochem, and like even social sciences, everything related to climate. And yeah, and like I also like as part of this masters, I went to University Center in Svalbard, which is like a tiny archipelago like north of Norway. And I did some courses in polar meteorology and oceanography over there. And that was very different because again, like I'd done some field work in the trekking company, but it was not scientific field work. So this time I could actually do scientific field work, and it was again it was a very beautiful environment, but it was also like quite cold. So it was like a bit hard to do field work over there. It was very, very enjoyable. And yeah, so I did a semester there, and like yeah, and now I'm still continuing my masters. I'm yet to start my thesis, but right now I'm working as a student assistant at Max Planck Institute of Meteorology, and I'm working with the tropical cloud observation group. So they have this like weather station at Barbados, and it's called the Barbados Cloud Observatory, and it's pretty cool because it's like a small island near South America, and like all of the clouds that come towards the island, they are like uninterrupted, so you can study all sorts of tropical clouds. So you have a lot of data about these clouds, and that's what I'm working on right now. And yeah, I'm hoping to start my thesis soon. But yeah, that's my introduction.
That's awesome. So we won't spend too much time on this, but maybe both of you could share a little detail about the current master's programs you're at. Not sorry, not current, but whatever courses you did in the various master's programs, and how you applied to them. Just a few tips for students who may be in the audience. Is that good?
Yeah.
Sahil?
The master's program was a two year MSc. And the way it's designed is, well, when I did it, it was designed in modules essentially. So the idea is that the master's program should be accessible to both students who have like just finished their undergraduate and come into study also, but it should also be accessible to people who are like sort of civil servants working in NGOs, private sector, etc., to come into the program, do a module, get a certificate, and leave, because they might need to learn something very specific or something of that sort. So our course, the 2 years is split into short modules. Modules of about, I think each module was, I think, 4 weeks or 5 weeks or something of that sort. And so how it's designed is um, so your first year is essentially um, classroom based, and your second year is split into a thesis, I mean fieldwork, and then thesis for one semester each. The classroom programs are designed to sort of give you initially for your first semester when you first walk in, you kind of spend time understanding the resource. So you spend time understanding. I'm hesitant to say science, but it's the science behind water. So we spend time understanding how, let's say, a river functions, how wetlands function, how does groundwater work, what is an aquifer, why do they function this way, and things like that. And an added note to this is that all these, the way our program is designed is that it was 80% taught um, by faculty that were outside my university essentially. So yeah, I remember at the beginning of my course, Professor Jagdish Krishnaswamy from A3 took sessions on river ecology. um, Professor Lele would come in and take sessions on other aspects, things like that. So you'd have people who are in the field doing research very specific to what you're studying, who would come and teach you for 3-4 sessions and so on and leave. So the good thing about that is you sort of build networks with this water community, because the community itself in India is quite small, and then you start to engage with practitioners over there. So you spend the first semester basically understanding scientific concepts in water, and then you sort of move on to understanding more of the political, social, and economic concerns around water. So you spend time understanding. We do work on history, on institutions around water, histories of water usage. We spent almost 2 modules just understanding dams, why we constructed large dams in the past, what its functions now, the politics behind dams, things like that. We also spent considerable time understanding the social nature of groundwater. For example, how Indians use groundwater, how groundwater is managed, uh, participation in communities, and things like that. So the second semester is largely spent on social concerns and courses on urban water, and we had a small course on climate change as well to teach us just climate change in isolation, but it was pervasive throughout the course. If you're studying water, you are essentially also you're dealing with climate. So that was our first year, and then you sort of break out into your field work, where you spend 4 months in 4 different locations. You spend a month in Gujarat understanding something called participatory irrigation management, basically trying to understand how farmers collectivize and participate to manage irrigation. You spend 1 month immersing yourself there. You spend 1 month in Odisha with, we spent it with Gram Vikas to understand how you implement rural drinking water and sanitation works. Basically understanding open defecation, understanding toilets, sanitation, and things like that. Then you spend another month in the drylands of India, in Madhya Pradesh, with an organization that's primarily working on something called watersheds, watershed treatments. They are essentially they work on understanding how you conserve soil and water in areas that receive sparse rainfall, right? You spend a month there, and then you spend another month in Maharashtra studying groundwater exclusively. So basically understanding how aquifers that hold groundwater function, how wells and springs work, and basically you do all of this work on the ground with the organization, and you get to understand how people participate to manage these resources. So you spend 4 months there. You sort of pick up a research question from these 4 months based on your interest and what you've experienced, and then you finally spend a thesis. You write a thesis based on your work. Yeah, that's really about it.
Okay. Sahil, while we are on the topic, perhaps you could share some of the slides that you had prepared and some of the photos of your various field trips.
Yeah, can I have my presentation up? Yeah, so to give you context, I mean, the way we did our fieldwork was flipped to how I described it because of COVID, essentially. So when I was supposed to do fieldwork, second wave was going on. So instead of actually doing fieldwork and then doing a thesis, we had to flip our semester. So we actually did a thesis sitting at home and then went to fieldwork a little later. So what I will do is I'll just quickly describe some of these pictures, and Kripa, just like stop me if this is if it's getting quite long and you want to come back to something later. Uh, does that
Sure,
work?
sure. Yeah.
So speaking about participation, right? This first photo is from Gujarat, where on the left you can see what is a canal. Canal essentially transports water from a large reservoir made by a dam to the farmlands where water is needed for agriculture. But basically, we got to visit some of these canal networks and try and understand how they function and how communities are using canal networks and irrigation water for agriculture. But what is interesting is I show these pictures because of a very particular reason. I mean, so this village that I took this picture from lies somewhere in the tail of the irrigation network. That means as you have a reservoir over here, and as water keeps passing down, the last end of the irrigation network is where this village lies. And typically, tail end villages that receive canal water don't receive too much water because by the time the water reaches there, it's either evaporated, seeped into the ground, or it's been appropriated by people upstream. So this village had a very nice solution. Essentially, what they did is for irrigation water to function, you need water to come in decent quantity and at the right time, which is if you don't get the water while you're sowing a crop, then there's no point. If it comes later, it's just wasted water. And this village was having a lot of problems. They said, okay, we are getting water, but it's coming late. It's not. It doesn't come at the time we wanted. Some years a lot of water comes. Some years nothing comes, and so on. So what they did was this. On the right, you see a lake. They basically constructed this small lake, and what they said is, whenever canal water comes through this canal, we won't use it. We'll just send it into this lake. Let canal water come whenever it wants. Let rainwater come. Let whatever come. Let's just send it into this tank. So this lake. So they send water into this lake, and it kind of collects here. What they do after is quite interesting. They take water from this lake and pump it into this well that you see on your left hand side. So what they take all this stored canal water and they just send it into this what looks like a well, but it's actually not a well. It's lined in the bottom, but they redirect it here and it kind of fills up, and you can see the all the pumps around this well. Essentially, everybody in the village, whoever wants water, I think there are about 45 pumps that are attached to this single well. So the water resource to this village is supplied by this one source, and each of them sort of puts has a pump that is attached, and the community itself manages the maintenance of this structure. Each of them pays a small tariff, but what is important is that it's a single resource. So they could have all drilled individual bore wells in their houses and got um, water for their crops. But they realized that in that case, they will sap the groundwater and it's a lose-lose for everybody. So instead of that, they said, we let water collect here so that we can see water, we can see it in our well, and then we can see how to use it. So that's just one example of how a community, is using a resource that is very variable to sort of feed their crops. But something that you don't see in the picture is that this is also it's a very like upper caste rich village. Even though they're in the tail, they could do all of this because they had some amount of agency and money to perform these kind of works, right? Which is quite telling, because in most tail end villages, this is not the case. Um, yeah, so that is just one example of how communities are using resources. Yeah, I think I'll just quickly show you another picture. Yeah, so this was in the drylands of India in Madhya Pradesh, and this was during May. And when you basically go to Madhya Pradesh in May, this is how it looks like. It's just bare. Everything is sort of dry, and yeah, temperatures are soaring, and it's quite difficult. But there are tribal populations that live here that still need to manage that live here, right? So they need water resources, and they need agriculture. They need a way to sustain and live. So there a method of trying to save water in these type of regions is what is called watershed treatment. Watershed is any area where rainwater basically collects and channels into a single location. These small hills that you see over here, that are bare, are used for these watershed treatments. The logic is simple. It's that even though it's dry, they do receive rainfall. But the problem is when it pours, it pours. It rains, and all the water just kind of runs off into rivers, down the stream. I mean, down the watershed or whatever. But when it rains, they're not able to use the water because it's all going away. They need to figure out a solution to make the water slow down. Why slow down? As the water slows down, it kind of seeps into the ground, and then sort of increases your groundwater table. So how do you make water slow down? You implement these what are called watershed structures. And so on the left is, let's say, you can see the small line in between, that is like your stream essentially. And you build small structures made of resources that you find in and around. You're not bringing anything from outside, and you build these small things. This on the right, what you see is a Gabion structure, which is one of the biggest watershed structures. All the other structures are much smaller than this. And these structures, essentially, when it pours, when you build successive structures like this, they sort of slow down and arrest the flow of water. And water then now is allowed to seep into the ground and sort of enrich the groundwater table of the area. And the results are this, right? So it's really interesting when you walk through these dryland areas, you will find these patches of green, and it looks really odd because when you're standing on top of a mountain, you will see a very clear green patch you will see a lake like randomly and things like that. You immediately know there are watershed treatments being done there. So if you contrast it to this dry area that you see here, after post watershed intervention, your landscape itself sort of changes um, um, due to your intervention. And then finally, what it's doing is because there is now water in the soil and it's getting saturated with water, it yields water now in areas where you can receive groundwater. And for structures that are built much higher in the shed, you see the benefits much lower. And then this lake is just fed by groundwater that is present below. And because of your treatments that you do on top of allowing water to seep into the soil, it yields this water back down below, and this water now stays throughout the year. When it rains, the lake gets bigger and it's filled with rainwater. When there's less rains, the groundwater supplements the lake. So you have water in this dry land area 24/7 through the year. So there's emergency lifeline water available in areas where you're just not going to see rains except for that one or two, except for the short spells, right? So yeah, I'll just stop now, and I'll bring up other pictures as and when. We'll see.
Yeah, that sounds great. Yeah, so let's go on to Amrita. So, Amrita, what kind of courses did you do? And can you show some, maybe just like Sahil did, you can give us a taste of what kind of field trips also you had during your course.
Yeah. Can I have my presentation up? Yeah. So maybe first a bit about the course that I'm doing. It's called Integrated Climate System Sciences, and like it's quite interdisciplinary. Like you can do courses from like physics of climate to like biogeochemistry, or even like economics and social sciences, but everything related to climate. And it's again like a 2-year master program. And the whole idea of this master program is just that like it's like you get insights into like different disciplines that are related to climate, and then like you choose what you want to do. So it's like in the first semester you have to do all of these courses like meteorology, oceanography, soil sciences, economics, sustain, like everything. So it's very like intense in the first semester because you were essentially doing every bit of it. And then like in the second semester you choose what you want to specialize in. And then in the third semester you do like a small project, which is like like a pre-thesis project sorts. And then in the fourth semester you do your thesis. But again, it's like very flexible. You can do courses outside of the master program as well. Like you can take it from the Institute of Geography or Institute of Meteorology or anything, as long as it's related to climate. And you can take as many courses as you want. So that's what I did. Like I was supposed to do my thesis now, but I just wanted to do a lot more courses because I'm like relatively new to this field. And so yeah, like maybe I can tell you guys about the courses later. But yeah, like Kripa also mentioned that I should talk about the application process. So yeah, it's this program. The application period runs from 15th Feb to 31st March every year, and like every foreign university, you have to write a statement of purpose, like telling about like why you want to do the course and like what kind of courses you like, what kind of courses you want to do within the program itself, and why do you want to study in that that university. And then you have to submit a CV, your transcripts, and your English language skills. And it's like a fairly simple process to get into the program. And also like it's a very international program. Like it's based in Germany, but like we're all from like different places. I think half of our classes like they're Germans, but then like most of us are like from outside of Germany. So it's a fairly simple like application process. I'm not really sure about like how tough it is to get in or not, because yeah, I'm not really sure about that, but I think it should be nice if it should be easy if you've done something related to environment, because they are looking for people who want to switch into like who are looking to switch into disciplines, because that this is essentially a place where you can like transition from something like physics, which is what I did, into something else like economics, or maybe even like climate communication, because we have courses like that. And maybe now I can come to the courses that I've done at the university. Like these are just some of the courses, and probably some of my favorite courses as well. And so yeah, we have like courses ranging from like climate modeling, oceanography, meteorology, but also you can like do very specific courses just like sea ice. So we were just like studying everything about sea ice physics, like dynamics. Then like we had like a lot of people coming in and talking about their field experiences in like on ships and going to the sea ice and working there. How do you take measurements? So that was very, very interesting. And then we also had a course in biogeochemistry, which was like this course on soils, where we just like, it was a field course where we just went to like the like some parts in the northern Germany, and like we just did like field work over there. And here you can see some pictures. So yeah. And then like we also had courses in climate communication, and Uncertain 2 Degrees was like a climate communication course where we basically had to like try and communicate climate science effectively. So we had like all of these mock trial conferences or like interviews that we had to organize ourselves, and then like we would practice about like how would you talk to like if you're a scientist, how would you talk to like someone from an oil company, or like how would you talk about like climate science to like kids, or yeah, like those are just a few examples. And then we had like a course in just like climate communication, where we were again studying like papers from social sciences about like how effectively you can frame climate news, or like how do you know if this climate news is reliable or not. So yeah, that was very interesting for me as someone who's never done this before. And I think it's very important if you're studying something as climate sciences. You can't just study physics of it. I think you have to study the whole part of it to really like be in the field. And then we had like climate policy scenarios, which was more like economics and sustainability. So we had like intro course in microeconomics, and then like we moved on to like sustainability. And then we also had this integrated assessment model, which was like combining like economics into normal climate models. So it was just like an intro, but like just to know that there's so much that you can do, just that there are so many possibilities, and there's like space for everything in climate science, not just like hardcore I don't know, physics, or yeah, like there's a lot more that can be done. Like there's a lot of space for each and every one in climate sciences. And it was a very good introduction for us, because a lot of my classmates, we had a background in natural sciences, and then all of us transitioned into like say meteorology or oceanography, and then like climate communication, then climate economics. So it was like just an intro, and then you get to specialize. And like the other really nice thing was that you have an option to do courses outside of the university as well, which is what I did. Like I went to this place called as Svalbard, which is like far up north, and it's in the Arctic Circle. It's really, really pretty, and it's a very small town. And yeah, I did courses in polar meteorology and oceanography, which is basically studying the atmosphere and the oceans. And the great part about this whole experience was that like I got to do a lot of field work. And these are some of the pictures from the fieldwork for meteorology. Like that's some of my classmates setting up like instruments, and that's an eddy covariance measurement station. And it basically like measures simple. It's amazing, because it's just like measuring like simple things like temperature, wind, humidity, but with just that data you can like know so much about the local processes. And like for me, I'd never been out in the field, and I've not done hardcore modeling or programming as well. But then like when I did like some data analysis with the data that I got myself, it was so much more intuitive, and like I also like could understand the processes, just like the physical basis, so much more like very simply, because I was there, I did it. And I think like I would definitely recommend anyone who is like either in a very theoretical position to do like something that's lab or outside, because it really bridges the gap between that. And if someone's a field person, then they should definitely do programming. Like for me, I'm learning now that I need to do a lot more programming, learn a lot more programming, and which is what I'm like working on now. But yeah, so this was like one of the field work that we had in one of the islands over there. And yeah, it was a very pretty place. So we got to see some northern lights. I was there from start of the summer to end of the, not end, mid of the winter, I think. And the fieldwork was really grounding. Like it was, the environment wasn't like easy, and we also like carried our own instruments, and like not everything works at the same time. Like you have to be a lot more patient than you usually are. And also like you're working in a team, so you have to be considerate about like how other people are feeling. So it's when you're out in the field, it's not just about science anymore. You're just like also thinking about like how others are doing. So you can't get the whole group's moral down just because you're not feeling one day, or like one day you're just feeling off or anything. So it was a lot of team effort, and it was like I was very grateful to have like some nice people around me. It was very motivating. And again, like coming to like teamwork, I did like a ship-based research as well. And like we were on a ship for a week, and we carried out like small measurement experiments. And like this is one of my friends conducting a CTD experiment, which is basically conductivity, temperature, depth. So you send this whole device into the water with like a pulley sort of a mechanism, and then like these bottles open up at some point that you can control them, and then they fill up water in at that point. And then you get the bottle up, and then you just know what, like while like doing some experiments on it and like just analyzing the data, you know what the water sample, the properties of the water sample are. And that can actually tell a lot about what's happening down in the oceans, like about the currents, about like like if just the properties can tell a lot about what's happening down there. So yeah, we were on the ship doing this, and again it was like a very different experience from land, because you couldn't get out of the ship. You were just there, and like you had night and day shifts, so you had to be like healthy and also conduct these experiments. And so we all tried not to get seasick, but we did end up becoming seasick. So that was very interesting, because then the other people had to like take over, and then like you work about for all of these things as like a group always. So yeah, then we all recovered, and then like it just continues. You just keep doing experiments. And again, like this is we had to wear these big suits all the time, so that like if by mistake any one of us falls off or anything, and the water is pretty cold, so we had all of these trainings about like how to be there. And and we also had to like carry out experiments and like routines in the night, and this is one of those where we were recovering a mooring. A mooring is essentially like this long piece of like rope, where at every point there's like these measurement devices attached, and it's there for like maybe like a year or something. So like you have a whole time series of like water properties at each level, say like 100-meter or 200-meter depth. So you have a whole time series, which is very different from a CTD experiment, because like you're just putting it down once and taking it up, so that you don't get time series over there. So this was done during the night, and like once the mooring is out, you have to like open them up and make sure that like the data is fine, or like all of those things. So it was like really fun. And I got to be outside, which is like something that I'm always looking forward to. And I also got to do some physics. and some sciencing. And yeah, that was a great experience. But yeah.
So just when you were talking about CTD, I saw Sahil's head was like, yeah, yeah, yeah. So it feels like, whatever you did, so many, both of you, when Sahil was talking about just runoff versus, uh, uh, what was it? What was it that you said? Runoff versus seeping into the soil.
Infiltration.
Infiltration, right? It seems like such a simple physics concept, and it's probably been implemented for centuries. Similarly, like what Amrita said about CTD measurements, it seems like such a simple thing to do. You just go and grab some water at a particular depth and go ahead and do your things. So often I feel like, Mm. I personally feel a lot of frustration that these simple things are not done to an adequate degree around me. So, what kind of do you feel similar frustrations, first of all? And do you have a wish list of what could be there around you? What all do you want to do? Um, like for Amrita, it would be about what all do you wish could have been there back home? I mean, from your point of view, could be here around us. And Sahil, like, what are your frustrations about what is lacking in the Indian system?
Um, so I think one thing that comes to mind is that finally water is is a social and political issue. It when the tire hits the road, this is a social discipline, and that when I was on the field, that was revealed quite a bit. When you go to a village, one hamlet receives water, one hamlet doesn't receive water. Your instinct is to think pipe is broken, there's not pump capacity, things like that. But 9 out of 10 times there are social problems as to why somebody is not receiving water and somebody is. But given that, and given that the management is finally a management of a physical resource, there is a lot of science communication involved. And so you need to be able to uh, take the science of, let's say, groundwater. India is one of the largest users of groundwater. Groundwater is stored in aquifers, and aquifers is a physical thing that works according to physical laws, which can be as complex as you want it to be. There are hardcore scientists that are working on understanding aquifers as aquifers, but that is meaningless to somebody who's to a village that has 5 wells and somehow manages to dry up their aquifer year after year. You need to translate what is happening there to them, which is a science communication problem, which um, I think a place where it gets quite interesting, because you'll have to not dilute but have a really clear understanding of these processes, so that you can sort of communicate it with people that you want to communicate with it. So an organization in Pune that I was with last month, Aquadam, their entire principle is just demystifying groundwater, because you think of groundwater as being something really, really complex, but their entire organizational goal is to work with people to, one, understand how they understand groundwater, and then you have this academic understanding of groundwater, and then how do you sort of work between these two to make knowledge sort of transparent and accessible with um, with everybody. So I feel like um, um, in with water, the communication is really, really important, and we saw that, like, on the field. It's often the people that have the best idea of how to manage their resources have a really clear understanding uh, of of the science behind how their resource functions. And there are also it's also oral histories, right? These are principles that have been passed on from generation to generation. On We have this spring in our village. This is how the spring functions through the year. Why do I know this? My grandfather told me that. whose great grandfather told him that, and that's how it's been working right now. And I mean, so a lot of our work was like going to these places and finally speaking to the people to understand how their resources function. There's like always a tendency, because I'm from an academic program, and we learn things about let's say groundwater. There's You go in with a certain positionality about what you understand about the subject, which can often be challenged by somebody on the ground, by the person who's living in that space. So what you understand as science starts to change a little bit. So I feel that's a huge challenge, because this is such a diverse country with diverse uses of water and diverse interactions of water. Like articulating those knowledges is like is quite a challenge, but it's quite it's a it's a exercise that teaches you humility finally. When you go there and you try to understand how a village understands its resources, really humbles you about the science that you know. So I feel like this whole traditional knowledge of resources is academic stuff that the background that we have is, yeah, it makes for a strange but interesting challenge.
Yeah, I mean, I think I would definitely agree with Sahil on this about like how fieldwork, once you go into fieldwork and then like once you start applying that knowledge, you realize like what you've learned in theory can be like quite different from what is actually there on field. And I talk about this from my experience at India Hikes, where like just like normal concepts in like science or something, I would just like go there and I would like talk, and they just like throw a question at me, and I'd be like, oh, okay, this is something that I've not thought about. And yeah, I think there is a lot of stuff in India happening already about like climate and climate change. There's a lot of outreach activities also, and also now like so many more programs are focusing only on climate change. And I know, Kripa, you're teaching something in at APU now for like climate physics, I think. So that's really nice. So yeah, and I do think like that we have a lot of potential to do like field work and make field work more accessible. But I do get that being out on the field, especially like in academia, can be a bit expensive. It's not very accessible. And like, for example, just like getting gear, it's something that's expensive. Like for me, like I've always like I've been outdoors a lot, so I've accumulated gear like through years, and it has been like, and like because I've been outdoors, I've also been in that network for me to like find things about like outdoors more easy, or like field work more easily than other people. But it's still tough, and like for someone who just wants to get into fieldwork, we need to like work on making those things more accessible. And especially like you can do so much fieldwork, like we have such great, like I don't know, geography in general. And yeah, like anywhere from the coastal regions to the Himalayas, like you could like carry out any sorts of small experiments, and even like just in the backyard, I think that can be done very easily. And yeah, I think that's what I was thinking when you asked the question. Yeah.
There's one
Okay.
thought that came to mind. Sorry, when Amruta was speaking, when I was in Madhya Pradesh, those dryland areas, this whole watershed process is championed by what they call barefoot engineers. And essentially these folks like use equipment that is rock, stones, sticks, etc., that is found within the local region to engineer their own resources. So the subject of watersheds and like treating these watersheds and engineering them itself is something that is so that is something that is very bottom up. So the people themselves have the ability to use the resources, physical resources that they have around them, to engineer the lands around them, and that is a science in itself, in studying watersheds and so on. So I just thought that was interesting. I mean, I didn't put pictures of the tools and the sort of measurement devices extra that they have. Even like just taking, because to do watershed treatments, you need to understand the slope of the land and all that. And if you go from outside and say to do slopes, you need to have this equipment, that's not going to work. So they have equipment that is made that you can use, that you can just make in a village using ropes and strings to measure slopes of large mountains and things like that, making the whole engineering part of it more accessible to the people who use it, right? So, I mean, that's just something I thought of.
Um, yeah, this conversation is fascinating, and it could go on for a very, very long time. Uh, and I hope it's just the beginning of many conversations we have with you guys. Like, it's been amazing learning experience for, or I think me definitely, but also our audience. But I think it is time to now pay some attention to the questions that have been both posted on the alumni portal as well as right now on the YouTube live um, comment section as well. So let me go through a few of the questions that were posted on the alumni portal. Um, okay, so here's one. What do you feel can be done at the individual level to avoid impacts due to climate change or water scarcity, as the case may be?
Like for me, I think I've thought about this a lot, and like I would say, like the first thing is just think about how do you handle your waste? Where does it go? And yeah, like how much waste are you producing, and like how is the waste handled in your city? Because like I feel like something like this goes hand in hand with climate crisis. Like sustainability really does go hand in hand with climate crisis. So like if you're very thoughtful about something like your personal consumption, like you are contributing to, like you are individually thinking about like fighting climate change. Yeah. And also like where does your food come from? I think here in the west it's like more black and white, but then like back in India, like I feel it's more complicated, but still I think it's important to know where the food is coming from and what kind of food that you eat. And yeah, it needs to be, again, like think of, like once you start thinking about sustainability, you're already thinking about how as an individual you're working for the like making things better.
Um, yeah, so in terms of water, water usually feels the impacts of climate change. It's the deliverer of the climate change impacts that we see. So flooding, drought, etc., are all driven by water. I'll just keep it very simple. If you're in a city like Bangalore and you're living in a house, or apartments or houses, whatever, the idea of like trying to adapt to climate change is to sort of reduce our dependence on the reservoirs outside, which are supplying our city with water. So essentially, if you are in a house, do consider harvesting rainwater. Bangalore has enough rainfall that is falling on our surface to provide yourself with enough drinking water for the year if you're able to store it. Um, so do consider harvesting rainwater and reducing your dependence on that reservoir outside, basically Kaveri water that is coming inside, right? Number two, if you're living in an apartment, take a look at your sewage treatment plant. It is quite important because, I mean, the water that we encounter on a daily basis, about 70% of that is finally going away as used water. We are consuming only X amount through drinking and cooking. The rest of it is kind of washes off whatever, whether it's cleaning, whatever, everything is finally going. So 70 to 80% is finally used water. Apartments generate a lot. treating that used water and sending it back for some purpose within your apartment or your house will reduce again your dependence on water from outside the city. That's coming at a huge energy cost and ecological cost. So yeah, I'll just keep it to these two, and we'll see where it goes from here.
Okay. Um, so there are a couple of questions about physics and climate science, and I'll just combine the two. One is what motivated you to transition from physics to whatever you're doing now? And another is, did either of you find your physics background limiting, or did you find your physics background to be transferable?
um yeah, like for me, it's, I would say, like meteorology or like oceanography, the thing that I'm doing is applied physics. Like, you are every, like, stuff in the nature, it has a physical basis, so I'm still very much doing physics. But like, I would say, like, when I was doing this, when I do courses in this master's, or when I was in Svalbard, like, because I hadn't studied all of these things in undergrad, and I had like classmates who had already studied like metrology or oceanography, like more specifically, I obviously had to like work harder. But it's all physics, so like it's just like very easily transferable. And I think, like, even for like my other classmates from Hamburg who've gone into like climate communication or like economics, like the stuff that I've heard from them, I think that you just like, it's, all of these skills are like transferable, and like you don't start from zero when you're like shifting a discipline. You're starting from the knowledge that you already have, and then you're shifting from there. And like that kind of knowledge always comes in handy, because you know something very different from what they know, and like you've been trained to think in a certain way which is a bit different from how they think, and that always comes in handy. And like my flatmate, she does climate communication. This is like completely different from what she did before. Now she's actually analyzing Twitter feeds about like what is the attention span of people reacting to like climate science, and she did like chemistry in her undergrad. So like now she's part of the communication department, but she's like coding these tweets. So your skills will always like come in handy. And yeah, it's you, as I said before, there's always space for you in this sort of a area.
Yeah, I think for me it's a little different because the course doesn't like what I studied does not employ like specific things that I did during my physics course. But something that's different is that the art of problem solving is something that will stick with you irrespective of what you do. So another important thing was during the 3 years of physics was very hard for me. And you have to often spend times on just really hard problems, and you have to get comfortable knowing that that problems are difficult and you need to really spend time understanding them. So in this 3 years, you kind of get practice on how to decipher problems that are extremely complex and difficult, and how do you sort of train your mind to approach these problems, which now help me today. So those kind of skills that you learn in the art of studying physics itself helps me when I'm studying something like water. And of course, it's like much easier for me to relate to the science parts of what I do. So remote sensing and stuff like that, where you're dealing with light and things like that, is much more faster to get. But I would say the skills that you gain as a physics student learning physics are the ones that really stood out to me.
Okay. There's another question. I don't know if you would want to engage in, I mean, I don't know how much you would be able to. How do you integrate issues of climate change in a teacher education course? So I believe this is about more what kind of maybe Amrita, since you were talking about how do you talk to kids, etc. Uh, can you share some of your experiences in your climate communication course where you maybe try to understand how, as a teacher, to incorporate climate science?
Yeah, actually, we had a course in climate communication where we are talking about like what kind of news is like uplifting and what kind of news is like really demotivating. And like since it's like climate crisis, most kind of news is like very demotivating. And like when most people read about their news, like they don't like they just it's like, okay, we don't want to read about this anymore, and that's where the action part ends. So we learned that like the framing of issues related to climate crisis is very important. So you frame it in such a way that like you also mention the impacts, but you also mention the actions. Also, like there's no point in like just talking about like the threats about climate action. Then there's like people are just going to lose hope. And actually, there's a lot of work that's been done in climate sciences now, and like we are like progressing, I would say, quite well. And there's still a lot of hope. There's also like so many people working on this. Like, and this is, I think, me studying climate sciences, I feel like this is my job to tell people, like, hey, there's a lot we can do. And at an individual level, also, you can do a lot. And collectively, we're even more like powerful. So, when personally, when you're talking about climate crisis, I would say, like, talk about it in a way that you mention the impacts, but also like what actions have been taken. And also there's a lot of actions that are being taken right now already. And yeah, definitely the framing is important. And actually, like the question about the teacher education, my mom teaches physics and science to like kids, and I've like spoken to her about this. And like she makes like she just asks kids to like read the news and like come back to her. And like often the news is about like crop failure or like air pollution or something like that. And then like she like slowly brings the topic to like, okay, why did the crop fail? Like, okay, this is because like there was not enough rainfall. Why wasn't there enough rainfall? Or like why was the season late? So just like you can, there's enough stuff actually happening around us. The climate crisis is not in the future anymore. It's very much present. We can talk about those things now and like around us in a way that doesn't scare people and doesn't like make them feel demotivated or like not hopeful at all, because there's a lot of stuff that's happening. Yeah.
Okay, lovely. What about you, Sahil?
Yeah, I don't think I have anything productive to add to that. To
It's all
to
and
to add.
in the whatever.
I think no. I think yeah. I think Amruta really put together quite nicely. So,
Okay. Um, Let me see if there are any other questions. Otherwise. Okay. So, for both of you, what movements and causes can citizens in India engage in to support systemic changes needed to curb fossil fuel emissions? And for Sahil, I guess you have answered this to some extent. What can individual and community level what do individual and community level successful water practices look like? So, for both of
mm,
you, what movements can citizens in India engage in to support systemic changes? What
mm,
do you
I
know of
think
any?
for about fossil fuels emissions, I'm not sure. Amruta would be better placed to answer that, I'm guessing. But citizen movements in general to bring about some sort of systemic change in these fields. At least in Bangalore, there are active civil society movements. I mean, Bangalore is blessed to have a really nice civil society anyway, and there are groups over here that are actively championing for some sort of lake restoration and lake revival in the city, which is now an emergency, right? I mean, the Bangalore, which is not historically not flooded, is now getting flooded on a yearly basis. the connectivity between lakes have to be restored and stuff like that. And there are groups, Friends of Lakes Bangalore is one of them, that meets and kind of sort of pushes for legislative changes to make even the governance of lakes happen. And I think each lake, depending on where you stay, I'm just talking about Bangalore, for example, depending on where you stay, each lake will have some sort of a citizen group that is actively looking after it. I think it's fun to just get involved. There's always fun things that are happening, and they do good work. So yeah, that is with regard to just getting involved.
Do you have any? Yeah, go ahead.
Yeah, I'm not really sure about movements, but I know like some of the networks in Bangalore that are working with environment, and I think Yugma network, they do a lot of stuff related to environment. And there's like, I think a lot of outreach happening as well where you can get involved. But like coming to like fossil fuels, I'm like not really sure about that, but I would also say like the dependency that India has on fossil fuels, like we can't really like just phase out fossil fuels or like coal, because we are a very big economy and a lot of like livelihoods depend on this, and our energy also depends a lot on that. So I think like we can't like compare something that's happening in the West very directly over here in India. And I'm not really sure if there are big movements that are like against fossil fuels or anything in India. I think it's like we are taking steps slowly about it. And like, yeah, but I wouldn't, in general, like this is my personal opinion again, like, and I wouldn't say that we need to like do this straight away. We are like a very big economy that's dependent on this, and we have like very high energy demands. And actually like there are like plans that are there, and they seem reasonable as of now, like. But yeah, I also don't know much into depth, but I've heard a lot about this where, okay, we need to like stop all the coal plants in India, but I don't think that's a smart idea, because it's a big, as I said, we have very high energy demands. It needs to happen slowly. And yeah.
Okay. So I have a few questions. One is for Amruta. You said, oh, look, there are lots of things happening, so you don't have to feel so bad. So can you give us some examples of what kind of research or whatever you've come across which is happening, which is giving you hope for the future? It could be either carbon capture or maybe some renewable, anything. I don't know what. Uh,
Yeah, like one, I think like just being now in this field where I'm like interacting a lot more with a lot more people who are working with climate sciences, I see like there's so much knowledge out there. Like we know so much more than we knew before, and there are constantly people working in this field. And like even when I was in Svalbard, like I actually like spoke to some people over there who had lived in that place for like 20 years, and they actually saw like the whole process happening. Like they see less ice and snow every time. They see that now. And like when I was talking to them, they were just like, yeah, like it's really, and they were researchers, and they were like, yeah, like it's like really bad and frustrating, but also it's good to know that there's so many more people getting involved in this research now. And it's not just strictly like one kind of research, it's so interdisciplinary, and there's so many more people who are wanting to do interdisciplinary work in this, not just research. There's also like industry work, and also like independent research organizations or think tanks that are like involving themselves in this. And like in the West now, there's also like political parties that are just made for like making, like they're called green parties, and they're just like their whole aim is to just make sure like the policies are made which combines scientific knowledge that is there. So if that's already starting to happen, I think like we do have some hope. And we have like so many, I think like even just the IPCC, I think it's like one of the most incredible things to happen, because this is like independent scientists working all over the world. They're all, they don't get paid to do this. They're doing this independently, and they're just putting out so much information together. And also IPCC has like three different like they have the physical basis, and then they have like the mitigation and adaptation strategies. So it's all like quite comprehensive, and it's different kind of researchers working together. So we have a lot of knowledge, and some of it is they're starting to use that slowly. And there's also this thing called a summary of policymakers, where they put together like a document where all of this science is explained in a much more accessible manner. So if you read something like that, yes, it's a bit disheartening, but also we know what the problem is. So now the point is to get to like working on it. So at least for me, that's what gives me hope. Like, okay, there's a lot that's been done, and I see people around me also getting more involved in it. Like people are seeing effects of like extreme events themselves. So it's not like I think it's very like a certain kind of people who still deny climate science. I think most people do understand what climate change is, because they're already seeing the effects of climate change. So just the awareness also, like, it makes me more hopeful that, okay, people are getting aware, so they're going to like start taking steps individually, or I don't know, collectively. There's already stuff happening. That's what I meant.
Okay. Okay, so I think we have exceeded time and we are coming to the end of our webinar. I have to say it's been really inspiring chatting with both of you, and there's a glow of pride somewhere inside. So it's been fantastic, and I hope to converse with both of you soon in some informal setting. Uh, so, if any of the viewers would like to get in touch with either Amrita or Sahil, do write to the alumni committee and they will take it from there. So, we'll end this now. Thank you everybody for joining us, and thanks a lot to Amrita and Sahil for sharing their experiences in such a um, uh, amazing way. And thank you to the alumni committee for putting this together. So,
Yeah.
thanks everyone.
Thank you, Kripa.
Thanks, everyone.